functions today. The definition of a function says that a function f from a set A to a set B is a relation that assigns to each element x in the set A exactly one element y in the set B. I do think we're pretty familiar with the x's and y's. We write xy points. So it says that each x gets exactly one y. I'm going to look and see whether this is a function or not. This x, -1, was given a single y, 13. I don't see any more negative ones. So that x value was given exactly one y value. This x value 3 was given the y value 4, and I don't see any other x values of 3, so the 3 was given just a single y value. 7 is also given a y value of 0, and it was given that one and only y value. 25, that x value, that input, was given a single y value, a single output of -6. So for that reason, this is a function. In fact, all of these up top are functions and the bottom ones are not functions. I'm going to show you how to tell. Okay, so this one is a function because each of the inputs had exactly one output. And that actually is pretty similar with this chart as well. Your x values are going to go to a single y value. Like the 3 went to just the -1, went to that single y value. 0 goes to 0, it only goes to one y value. -3 goes to 0, so it only goes to one y value. Now, I do recognize that this y value had a couple different x values going to that same y value, but that's not what's required. What's required is that the x's go to only one element in the y's. So the x went to a single y, x goes to a single y, to a single y, -6 goes to a single y. So this is a function also. When it comes to equations, it'll be a little different. We need to solve for y, so I will subtract x squared on both sides. So y equals a -x squared plus 1. What I do know is that no matter what x I plug in, I will get a single y. If I plug in a 0, I get negative, and then 0 squared plus 1 is 1. I got out a single y value. If I sub in some other x value, maybe I plug in like a 5 or something, negative, and then 5 squared plus 1. So like -25 plus 1 is a -24. But this x value that I subbed in, I got a single y value to go with it. And that'll happen with every x value that I sub in for x. So this is also a function. There's a way to tell this off of a graph, and it's called a vertical line test. Every vertical line hits a single x value. This one hit 4, great. And that x value hit a single point, so it was matched with a single y value. In this case, it was matched with the y value of 1. So what I'm drawing vertical lines for is to see if that x value hits any more than one y value. Let's see, the x value of 3, that hit a single point, so a single y value. At 2, I hit a single y value. In fact, every vertical line that I draw on here will all hit one y value and no more than that. So this one is also a function. Now the difference between those functions and these ones down here that are not functions, again, it has to do with that input, that x value. It can have no more than one y value, no more than one output. So this 0 hits an output or y value of 9. The same x value 0 has a second output, a second y value of 6. So because of this right here, this is not a function. That also means on my little chart here, the 1 went to 2 separate y values. So the 1 makes this not a function. Now the -3 goes to a single y value, the -2 goes to a single y value, the rest of them all went to a single y value. But if this happens once, it is not a function. And I'm going to do this equation similar to what we did before. I'm going to add the x on both sides. I'm trying to isolate my y, which is what I did up here. I got the y by itself. And in order to do that here, I have to take a square root to get rid of my squared exponent. And when I do a square root, I do a plus or minus on that square root. So plus or minus square root of x plus 1. If I sub a number in for the x, maybe I'll sub a 0 in, sure. Square root of 0 plus 1. Well, 0 plus 1 is 1, and square root of 1 is 1. So that means when I substituted in this x value, I got out plus or minus 1. I got out 2 separate y values with that single x value. I got a positive 1 and a negative 1. So for that reason, this also is not a function. And the vertical line test here, again, I'm testing each x value to see if it hits a single y value. It can't hit any more than one. And all of these vertical lines hit more than one y value. So like at the x value 2, it hits 1, 2 different y values. It hits like up here 2 point something and like negative 2 point something. So it hit 2 different y values. So this one also not a function. Since we know what a function is, then we can use function notation to write the input and outputs and an equation. Your input is the x, the output is a y, which we are calling y as f of x. So your equation, usually you can either write y equals, or you can do f of x equals. If we are going with function notation, we're going to call it f of x. You can actually use f of x, g of x, h of x, whatever. It's just a name for that function. In this case, they gave us a g of x function, and it says find each function value. So if I want g of 2 instead of g of x, that means I am replacing the x with a 2. And I'm going to do the same thing on both sides of the equation. So all of the x's on the other side are also going to be a 2. That means g of 2 is a negative 2 squared instead of negative x squared, plus 4 times 2 instead of 4 times x, plus 1. Do notice that I put parentheses around the x. I will do that pretty much every time to make sure that my order of operations is done correctly. So I do 2 squared, which is 4. 4 times 2, so 8, and plus 1. Negative 4 plus 8 is 4, plus 1, so 5. This means that g of 2 is equal to 5. Now, this time they're subbing in not just a number, they're subbing in the letter t. They're going to replace all the x's with a t. So g of t equals negative t squared plus 4 times t plus 1. In this case, I don't really need the parentheses. It's a variable just like the x was. So it said negative x squared without parentheses. I can do that with the t, negative t squared plus 4t plus 1. So here is my g of t. It's not a single number. That's okay. And then my g of x plus 2, I actually have the entire x plus 2 is going to replace the x. So on the other side of the equation, I will have negative and the entire x plus 2 is squared instead of their x squared, plus 4 times the entire x plus 2, and then plus 1. So we again replaced both of those x's with an x plus 2. There is a bit of simplifying to do here. Squared means multiplied by itself. It means I have an x plus 2 times another x plus 2. I will distribute this 4 to get a 4x and an 8, and then I still have my plus 1. We've got some distributing here. I will distribute the x, so I get an x squared and a 2x. I'll distribute the 2x plus 4. I still have the 4x, and then 8 plus 1 is 9. So we've combined those a bit. Now, there's something that I'm missing, and that's this negative. The negative was multiplied by all this stuff right here. So negative should be distributed to the x squared, 2x, 2x plus 4. Negative x squared minus 2x minus 2x minus 4, and I still have the plus 4x plus 9. Now I'll combine my like terms. So negative x squared, let's see, I've got a bunch of x terms. So negative 2x and negative 2x is a negative 4x. Negative 4 and positive 4 is 0. So I'm actually down to 0 x's. I've got none of the plain x's. The negative 4 and the positive 9 adds up to a 5. So I'm at negative x squared plus 5. This is my g of x plus 2. Okay, so the next one, they're calling it h of x. Sure, you can name it whatever letter you want. This is a piecewise function. There are 2 pieces of the function. You could be either using the x squared plus 1 or the x minus 1. And how you decide which one you're using is based off of what x value you get. Is the x value less than 0? Then you use the x squared plus 1. If the x value is greater than or equal to 0, then you use the x minus 1. So in this case, negative 1 is less than 0, so I'm going to have to use the x squared plus 1. So I will do my x is now a negative 1, so x squared plus 1. Negative 1 squared is a positive 1 plus 1, so we got a 2. h of -1 is 2. Next up, you've got h of 0, and 0 is in the greater than or equal to 0 section, so it's going to give you the function x minus 1. And your x value is now 0, so a 0 minus 1, which means 0 minus 1 is -1, h of 0 is -1. And last one here, you've got h of +1, which +1 is greater than or equal to 0, so it'll be that x minus 1 function again. And your x value is now 1, so 1 minus 1. So your h of 1 is 0. Okay, so we even did a piecewise function.